In this video, we will look at how to find the resistance in a parallel circuit, both when you need to find the total resistance and when the total is known and you need to find an unknown resistance. We'll be working with the equation here, the equation for the total resistance, and it's given as 1 over, and then it's 1 over resistor 1, resistor 2, and however many more resistors you have. You can actually solve this equation to get a simplified version that looks like this, and we would use this one if we were trying to find an unknown resistance. So let's look at some examples. What is the total resistance if you have resistors of 2 ohms, 4 ohms, and 8 ohms in a parallel circuit? So we'll start off by writing the equation down. We need to find the total resistance. So we're just going to plug in for resistor 1, 2, and 3, the resistances of 2, 4, and 8. And then we want to combine these together. So we'll have to get a common denominator, which would be 8. So I'm going to change those denominators. And I get 4 8s, 2 8s, and 1 8. When I add those together, I end up with 7 8s. So I have RT equals 1 over 7 8s. And I'm going to have to flip that, though, to get my final answer. I don't want a fraction 1 over a fraction. So if I flip it over, I get my final answer of total resistance is 8 over 7, or 1 1/7, which is approximately 1.143 ohms. This flipping part is a part that a lot of people miss, so we're going to see some more examples of that. Here's another one. What is the total resistance if you have 2 resistors of 3 ohms and 1 of 6 ohms in a parallel circuit? Again, start with the equation for total resistance and plug in 3 and 3 for resistors 1 and 2 and 6 for resistor 3. We can use a common denominator of 6. So we get 2 6 plus 2 6 and 1 6. We get 5 6. So again, 1 over 5 6 is what we have. So we're going to flip this over. And if I flip this over, I end up getting 6/5 ohms, or 1.2 ohms. Okay, so now we've worked through a couple of problems on how to find total resistance. We're now going to look at how to find the size of one resistor if we know the total resistance and the other resistors. So if the total resistance is 2 ohms and there are 2 resistors of 8 ohms each, what is the resistance of the third resistor? So starting again, same thing, we're going to use that equation for total resistance. So this time we know this, we're going to plug it in, it's 2 ohms. We plug in our 2 8s for resistor 1 and resistor 2. It looks like this. Okay. Now, I can't use this, sorry, let me go back. I can't really do anything right now, so I want to flip this. I'm going to flip it over to get this denominator into the numerator. When I do that, I need to flip this over. So I'm going to flip that over. And it looks like this, 1/2. Remember, there's a little invisible over 1 here, so 2 over 1. And so when I flip it, I get 1/2. And now here, I get 1/8 plus 1/8 plus 1 over r. There's an invisible over 1 here, but that doesn't matter. And this looks like that equation I showed you in the beginning, 1 over the total resistance. If I put 1/8 and 1/8 together, I get 2 8s, or 1/4. At this point in time, I can solve this equation by subtracting 1/4 from the side. So 1/2 minus 1/4, and that gives me 1/4 equals 1 over r. And I need to flip this, and when I flip it, I will get r in the numerator, and r in the numerator is what I want, and then we'll get 4 in the numerator. A lot of people make the mistake of just saying their answer is 1/4 at this point. So if you flip it over, you're going to end up with your answer being 4. So R3 is 4 ohms. And you can actually check your answers. By checking your answers, all you do is you take the equation, the normal equation for total resistance, and plug in the 8 ohms, and 4 ohms of the 3 resistors. Get a common denominator of 8, so this makes it 2 eighths, and you end up with 4 eighths. And if you flip 4 eighths, you get 8 over 4, which is 2. And the total resistance was 2 ohms, as given in the problem. So it works. Let's look at another example. Our final one, if the total resistance is 0.6 ohms, and there are 2 resistors of 3 ohms each, what is the resistance of the third resistor? So I cannot emphasize enough, start by writing down the formula for total resistance, then plug in what you know. Here's the total resistance, here's the 2 resistors of 3 ohms each. I'm going to take that 0.6 and I'm going to make it into a fraction. So 0.6 is the same as 6/10, and I could even reduce that to 3/5 if I want to. So I'm going to replace the total resistance with 3/5. And then I have the 1/3 and 1/3 and 1 over R3. And at this point, I want to flip this. I want to flip it over to make it kind of look like this equation, 1 over RT. I want to get rid of that clunky denominator. So when I flip it, I did 2 steps here. I flipped it and I got 5/3. I also put these 1/3 and then 1/3 together and got 2/3. So 5/3 equals 2/3 plus 1 over R3. I'm going to subtract 2/3 from both sides. And when I do that, I end up getting 5/3 minus 2/3, which is 3/3. 3/3 reduces down to 1. And if you had a hard time seeing how to get R3 out of that, I can flip it over and I see that the answer is 1 ohm. Once again, I can check my answer by putting in 3 and 3 and 1 here. 2/3, so 1/3 and 1/3 is 2/3, plus 3/3 is 5/3. Flip over 5/3 and we get 3/5, which is 0.6. And 0.6 is what was given as the total resistance. So, hopefully this video has helped you a little bit in finding the resistance in a parallel circuit. I can't emphasize enough to just start off with the equation, write it down, the equation for total resistance. Don't forget the 1 over part. A lot of people tend to leave that out. Just emphasize that, put it down. As soon as you get stuff plugged in and you can flip this over, put a 1 over this and flip this over, you end up with something a little more manageable. Good luck, and hopefully you will find some success with this.